What do you notice about these two pictures? So they both involve 10. When you look at the picture of the grocery store, we've seen this before, right? Some version of this. So it says 10 items or less. And so we think about who can get in that line. We call who can get in that line the number of items they have possible solutions. So if I were to think about what those possible solutions could be, right? I could get in the line if I have 10 items, or anything less than 10 items. So 1 item, 8 items, 9 items, 4 items. If I had 0 items, I could still get in the line. If I have 12 items, though, that's not a possible solution because I have to have 10 or less. The gas example is a little bit different because it says contains less than 10% ethanol. So I could have 9% ethanol, I could have 1.5% ethanol, anything that's smaller than 10, right? So it doesn't matter what the numbers look like as long as it's smaller than 10. So I also cannot have 12 because that's not smaller than 10, but I can't have 10 either, right? Because it has to be less than 10. So I could have 9.99999, but I can't have 10. So mathematically, we're going to represent these differently, right? So this x is less than or equal to 10 represents anything that's smaller than 10. And it's just an easier way to write it. Rather than write out all the numbers, you just say x is less than or equal to 10, and that basically says the same idea without writing all the individual numbers out. I could also say down here, right, x is less than 10. So similar idea, the only difference is x cannot be equal to 10, right? So I don't have that little line below it. So they look very similar, but they're very different in terms of one includes 10 and one doesn't. So that's just the main idea to start. If you notice too, they're both pointing to the left. Left means less than. One little idea though is if I flip the 10 and the x, I just have to flip the sign as well. So I could say 10 is greater than or equal to x. It means the same thing. Likewise, I could say that 10 is greater than x, and that means the same thing as x is less than 10, right? I'm just flipping the numbers and the letters, so I have to flip the sign. If I kind of build on the same idea, here we notice the information is the same. I just want to represent the top examples as a model. So I'm going to use a number line, and I want to focus on that 10. So I circle the 10. And to say the same thing, if you notice here, x is less than or equal to 10, that less than arrow looks a lot like the arrow that's pointing to the left. And so I'm going to move in that direction. But first, I'm going to shade that dot. Why do you think that is? Right, because x can be 10. So I'm going to shade whatever x can be. So x can be any of these numbers here that are smaller than 10. And those numbers can just keep counting down forever. The difference on the bottom example is that x is less than 10. So we know that x is still going to start at 10. But the difference here is I'm not going to shade that circle because x cannot be 10. Right? So I'm just going to shade everything below the 10, but I don't color the 10 in. So in Algebra 1 this year, the idea is instead of just focusing on one variables with inequalities, we focus on two. And these are going to look a little bit different. So if we add a y into the inequality, right, and we have two things that we're comparing, it doesn't really matter what attaches to the x or what goes as the y-intercept, right? The main thing to notice is when the symbols are the same, they both shade. Whereas when the symbols here are the same, right, you notice they're both not shaded. So this open dot and this dashed line mean the same thing. The shaded dot and the shaded line mean the same thing. So when you see less than or equal to or greater than or equal to, the idea is we're just going to shade. When we see just a less than or a greater than, we're not going to shade. That's it. I apologize for the extra noises. Those are planes and bugs and stuff because I'm recording this outside, but we are just going to switch over real quick and get you guys started here. So after you watch this video, you're going to click Next in Desmos, and in the screen you're going to see something that says change the x values in the ordered pairs below so that all 4 points are part of the solution set for the given equality. So anytime you see something like this in Desmos, you can change anything you want. I don't want you to do that because We want the problem to stay the same, but it does say change the x values in the ordered pairs. So here you notice that the dots are kind of spread out. We want them to be in the shaded part, right? So we want them to be a part of the solution. So here this orange dot, if you notice, we can zoom in on it too, right? That orange dot is on the line. So what that means is it's a part of the solution, right? Because this line is shaded, the inside's shaded, the orange is a part of it. So I don't need to change the orange, but I want to change the red. And so right now it's at 3, 4. So to do that, I want it to go left, right? So I could change it to a 1, I could change it to a 0, I could keep going, -1. It's just going to move further into the green. That purple dot is at a 4 right now, 4, 2. I want to change the x value to something that is going to be inside the green. So here I'm on the line, and when the line is shaded, that just means I'm a part of the solution set. So on this screen, you can make the dots anything you want. You just want to practice moving them into the shaded solution. Here, same idea, but the difference is, if you notice, right, this symbol is giving you a different line. So if I were to type equals right now, so I just click next to the less than sign. If I had equals, you see how that changes the line? Right? So this is what I started with. I just hit undo there. If I type an equals after the less than, it becomes less than or equal to. And that line becomes solid now. So that line includes anything that's on the line. So any of those dots that are on the line are a part of the solution. But when I have just a less than, that green dot and that red dot are not a part of the solution. And so what I want to do is move those dots inside. So this one says change the y values so that all the dots are inside. So instead of changing the first number, now I'm just going to change the second number. So 2, 1, I could change it to 2, -5. And you see that purple dot move down. The green dot is at -2, -1. I want it to go down so I can push it to a -2, right? So now it went from being on the line, which is not shaded, so it's not a part of the solution set. I push it down into the orange part that is shaded. Now it's a part of the solution set. On the slides that follow, it's going to be similar practice, but instead of being able to move the dots, you just want to see -5, 2. So if I go to -5, up 2, that's in the shaded part. So it's a part of the solution set. -2, 4. -2, up 4. That is white, so it's not going to be shaded. 0, 0, 1, -6. So if I go to 1, -6, right? So 1, -6 is on the line. If the line is shaded, then is it a part of the solution set? It is. So as you move forward, I want you to think about these examples. You have a few slides here and then a reflection. If you can do this, you are ready to retest, my friend. So good luck, and I will talk to you soon.